Hello dear students, welcome to Toppscholars. Today we'll be discussing about covalent bond. Now friends, there are some molecules wherein atoms generally prefer to share electrons with each other because complete transfer of electrons in these cases is not possible since these atoms are identical or these different atoms that are present in the molecule have zero or negligible electronegativity difference. So this ability to form a bond by the sharing of electrons is referred to as covalent bond. So now we can define a covalent bond, right? So a covalent bond is the attractive force which exists due to the mutual sharing of electrons between two atoms which have similar electronegativities or have small difference in their electronegativities. So compounds which contain covalent bond are called as covalent compounds. Remember friends, compounds containing covalent bond are called as covalent compounds. Now friends, generally a covalent bond is formed between two non-metals, right? Because between two non-metals, give and take of electrons is not possible, right? And so sharing of electrons generally takes place between two non-metals in order to become stable, right? But how do we represent a covalent bond? A covalent bond is represented by a dash, which means that one dash stands for a shared pair of electrons, right? So now let's discuss the formation of a covalent compound. Let's take an example of hydrogen molecule, right? So hydrogen molecule contains two atoms of hydrogen, right? And so we say that it is a diatomic molecule. Now, if we talk about the electronic configuration of hydrogen atom, it is 1s1, right? Which means that one hydrogen atom has one valence electron, right? So in hydrogen molecule, we have two atoms of hydrogen, right? So as you can see, each of the hydrogen atom has one valence electron, right? So now in order to become stable, each of these hydrogen atom requires one more electron, right? So what is hydrogen going to do in order to become stable? Yes, hydrogen simply shares its one valence electron. Now each of these hydrogen atom, what do is they simply share their one valence electron with the other hydrogen atom. And so in this way, each of the hydrogen atom completes its duplet and becomes stable, right? Now as you can see over here, these two hydrogen atoms have a shared pair of electrons. And this shared pair of electron results in the formation of covalent bond. So two hydrogen atoms are bonded to each other by a single covalent bond. Let's quickly have a look at the formation of hydrogen molecule. So here as you can see, we have two atoms of hydrogen. Each atom has one valence electron. So in order to become stable, what do these hydrogen atoms do? Yes, these two hydrogen atoms share their one valence electron with each other. And so you can see over here, these two hydrogen atoms have one shared pair of electron, which is nothing but a covalent bond, which results in the formation of hydrogen molecule, which is a covalent molecule. Now let's take another example. Formation of chlorine molecule. So chlorine molecule is made up of two atoms of chlorine, right? So we have chlorine single bond, right? So chlorine molecule, as we said, it is a diatomic molecule, which means that it has two atoms of chlorine, right? Now, if we talk about the electronic configuration of chlorine atom, it is 1s2, 2s2, 2p6, 3s2, 3p5, which simply means that the electronic configuration is 2, 8, 7, right? So from this, we can say that chlorine has 7 valence electrons, right? So now, each of the chlorine atom has 7 valence electrons. So in order to become stable, chlorine atom requires one more electron, right, to complete its octet. So in order to become stable, what do these chlorine atoms do is, each of the chlorine atom shares its one valence electron with the one valence electron of the other chlorine atom. So now as you can see over here, each of the chlorine atom shares its one valence electron with the other, right? And so each of the chlorine atom completes its octet and becomes stable. So here you can see the two chlorine atoms have one shared pair of electron, right? This one shared pair of electron results in the formation of covalent bond. So two chlorine atoms are bonded to each other by a single covalent bond. Let's have a look at the formation of chlorine molecule. Two chlorine molecules, as you can see, they have 7 valence electrons. So in order to become stable, they need one more electron. So what do these chlorine atoms do? Yes, share their one valence electron with each other. And so each of the chlorine atom completes its octet. So now you can see these two chlorine atoms have a shared pair of electron, which is nothing but the covalent bond, which results in the formation of chlorine molecule, which is a covalent molecule. Now let's discuss about the classification of covalent bonds. Covalent bonds are classified into single covalent bond. Single covalent bond means, single covalent bond means that the two atoms in the molecule are bonded by a single covalent bond. Let's take an example to understand this, right? Let's take hydrogen chloride molecule, right? Hydrogen chloride is made up of hydrogen and chlorine, right? So here, as you can see over here, hydrogen atom we have, right? We know that hydrogen atom has 1 valence electron, right? And chlorine atom has 7 valence electrons, right? So in order to become stable, hydrogen needs 1 more electron and chlorine also needs 1 more electron. So what do this hydrogen and chlorine atom do? Hydrogen atom shares its 1 valence electron with the chlorine atom. That is, it shares its 1 valence electron with 1 valence electron of chlorine atom. And so in this way, hydrogen completes its duplet and chlorine completes its octet. As you can see over here, hydrogen and chlorine have a shared pair of electron, right? And this shared pair of electron results in the formation of a covalent bond between hydrogen and chlorine, right? So this bonding that is between hydrogen and chlorine by the sharing of electron results in the formation of a single covalent bond, which is represented by a single dash. Let's quickly have a look at the formation of hydrogen chloride. As you can see, we have hydrogen atom, right, which has 1 valence electron, and chlorine atom which has 7 valence electrons, right. So hydrogen atom shares its 1 valence electron with the 1 valence electron of chlorine atom, and so hydrogen completes its duplet and chlorine completes its octet. And as you can see, hydrogen and chlorine both have one shared pair of electrons between them, which results in the formation of single covalent bond between hydrogen and chlorine. Now let's discuss one more example of single covalent bond, that is water molecule. Now friends, if you look at water molecule, it is made up of 2 atoms of hydrogen and 1 atom of oxygen, right? We know that each of the hydrogen atom that is present has 1 valence electron, right? Whereas oxygen atom has 6 valence electrons. So in order to become stable, hydrogen needs 1 more electron, whereas oxygen needs 2 more electrons. So to become stable, each of the hydrogen atom shares its 1 valence electron with the oxygen atom, right? So in this way, hydrogen atom completes its duplet, whereas oxygen atom completes its octet. And now as you can see over here, hydrogen and oxygen have 2 shared pairs of electrons between them, right? Which results in the formation of single covalent bond between the oxygen atom and the hydrogen atom. Remember friends, over here, oxygen and hydrogen atom have 2 shared pairs of electrons, but one oxygen atom and one hydrogen atom has 1 shared pair of electrons, right? And in this way, we have 2 shared pairs of electrons, right? Which results in the formation of single covalent bond between oxygen atom and hydrogen atom. So in this way, we have 2 single covalent bonds which are formed between oxygen atom and hydrogen atom. To learn more about this topic, download Toppscholars app.